Alright, what is the equation of the line shown? Alright, well the equation of a line is y equals mx plus b. I need to figure out the slope and the y-intercept. Y-intercept is super easy, right, where the line crosses the y-axis, so it's b equals -3. Now the slope is what? Alright, here's one point, and here's another. So I just go up one, that's my rise, and I go right one, that's my run. So my slope is 1 over 1. Right, plugging this information in, oops, and simplifying, I get this. Done. Alright, what is the slope of all the lines parallel to this line? Okay, first thing you have to understand is that the slopes of parallel lines are equal. So all I need to do is figure out what the slope of this line is, and then I have my answer. Alright, so I have, this is my equation. First thing I need to do is isolate y, so I get it in slope-intercept form. Divide by 4, then I get y is equal to negative, there's a 1 on top here, be very careful with that. Alright, so it's -1/4 x, then divide it into the right side, and I get 3 over 2. But my slope is going to be right here. And to answer the question, what is the slope of all lines parallel to this line? Well, the slope here is -1/4, so all lines parallel to it will also have a slope that's -1/4. What is the slope of all lines perpendicular to this line? Alright, perpendicular. Alright, remember for perpendicular, the slopes are opposite reciprocals. Alright, so here's my equation. Then I'm going to add 15x. I get 9y is equal to 15x plus 3. I'll divide by 9. And y is equal to 15 over 9x plus 3 over 9. Simplifying all of this, I get 5 over 3x plus 1/3. Okay, now I'm focusing in on the slope here, 5/3. To find the slope of the lines that are perpendicular to this line, I need to take the reciprocal of this slope and make it the opposite sign. In this case, it would be negative. And that answers the question. Done. On to the next. Determine f of 0, f of 1, f of 2 for the function below. Alright, f of 0. How do you do this? Well, this is my x value here. This is my x value. Alright, here I have this restriction. I only look at this expression for x values that are less than 1. Well, this is an x value less than 1, so I'm going to use the expression 10 minus 7x. In this case, x is 0. So I end up with 10 minus 0, which is 10. Oops. 10 minus 0, which is 10. So f of 0 is 10. On to the next, I have f of 1 is equal to, well, 1 is not less than 1 here, okay? But here it says x is greater than or equal to 1. All right, equal to 1, I'm working with 1, so this is the expression I work with in this case. So it's 8 times 1 minus 5. 8 minus 5 equals 3. So I have f of 1 equals 3. Alright, then I have f of 2. So in this case, 2 is greater than or equal to 1. I use the second expression once again. 8 times 2 minus 5 is equal to 16 minus 5, which is 11. F of 2 equals 11. Alright, that's 67. On to the next problem. All right, solve by graphing. All right, perfect. In these two equations, they already give them to us in slope-intercept form. So they're very easy to graph. All right, so for the first equation, I go down 2, and then I go down 1, right 1 for the slope. Keep repeating that over and over again. And then I have 4. I'm going down 3, right 1. Down 3, right 1. Down 3, right 1. Boom. Up 3, back 1. So here's my second line. And here is the point of intersection. That's what you're looking for. That's how you solve the problem. They intersect at, what is this point? Go to the right 3. Now, finding a point is different than applying the slope. That's essentially the opposite. So first I go right 3, and then I go down 5. It's a very common mistake that students mix up the slope with finding a point. All right, so x first, and then y second. So there's my solution, 3, -5. Solve by graphing. All right, a little more work involved in 71. We have to get each equation in slope-intercept form. So I'll call this equation 1, call that equation 2. For equation 1, all right, let's isolate y. All right, just take it step by step. It's not that difficult. Simple stuff. Just take your time. All right, then I have my slope, which is going to be 1/1, and my y-intercept is 2. Cool. On to the second equation. Negative y equals -3x, and then divide by -1. Y is equal to 3x. So my slope here is 3/1. Y-intercept is 0. All right, let's graph these equations now. So for the first equation, I go up 2, and then I go up 1, right 1, up 1, right 1, up 1, right 1, down 1, back 1, down 1, back 1. All right, there's my first equation. All right, and then for the second, I start off at 0, and I go up 3, right 1, up 3, right 1, down 3, back 1, down 3, back 1. Alrighty. There's my solution where the lines intersect, so I go right 1 and up 3. So the answer is 1, 3. On to the next problem. Okay, these two equations are already in slope-intercept form. Perfect. That makes our life easy. All right, first equation, I start off at -2, then I go up 2, right 1. And then the next equation, I go up 2, and I apply the same slope, up 2, right 1, up 2, right 1, down 2, back 1. All right, notice that the lines are parallel. So is there a solution? No, there's no solution because the lines never cross. Done. Next problem, a bit of work required. Simple stuff though once you get the hang of it. All right, so for the first equation, I have 10x plus 2y plus 2 equals 0. Just take your time, easy stuff. Just converting it into slope-intercept form. divided by 2, y is equal to negative 5x minus 1. So slope is negative 5 over 1. Y-intercept is negative 1. All right, for the second equation, 5x plus y plus 1 equals 0. All right, subtract 5x. Y plus 1 is equal to negative 5x. Subtract 1. Y is equal to 5x minus 1. Slope is 5 over 1. Y-intercept, negative 1. All right, let's graph these equations. So I start off at negative 1, and I go down 5, right 1. Then I go up 5, left 1. All right, there's my first line. And then for the next one, I'm going to go down 1. Down 1. And then I go... Oh, I left out the negative. Then I go down 5, right 1. Up 5, back 1. And it's essentially the same line. All right, so the lines overlap. So they intersect at all these points. It just goes on forever. So that's why there are infinitely many solutions. All right, on to the next. Solve by substitution. Okay, this problem's very easy. They already isolated one of the variables for us. So I take this expression here and I plug it in for x in the other equation. So I have 2y minus 10 times 2y plus 18 is equal to 0. Distribute. I get 2y minus 20y minus 180 equals 0. All right, now I have like terms. Negative 18y minus 180 equals 0. Add 180. Negative 18y equals 180. Divide by negative 18. And y is equal to negative 10. Awesome. Take this and I'll plug it over here and solve for x. So I have x is equal to 2 times negative 10 plus 18. So I get negative 20 plus 18, negative 2. All right, so my answer is negative 2, negative 10. It's as simple as that. Done. Solve by substitution. All right, here we have a system, and we have one of the variables isolated already. Perfect. So I'll take this expression and substitute it in for y in the other equation. Always the other. All right, now I'm going to try to isolate the variable. I get 1. Oh, this cancels out. So I get 1 equals negative 3. Oh, that made life easy. Now you just need to know how to interpret this result. So I end up with an equation that is not true. This is false. If that's the case, then there is no solution to the system. Done.